Hello and welcome to my channel. Okay, so last time when I tried to set it up, expose a computer to the network, so a computer running in my local network to the cloud, to like the web outside of this, it was very specific to serve like web pages or like you wanted to expose a site, things like that. But in this particular case, I found that like if I wanted to do something else, like for example, access from my laptop or any other computer to access one of the machines locally, I'm kind of like limited. So I was wondering like how can I access computers in my home lab or like my home um, through from the outside without having to open holes into my internet connection, like like opening ports, exposing all those kind of things. How I can access my Synology server, the web version, or I can access certain documents from when I'm like remote, right? So on that front, I found well, Fly's private network is great when you wanted to build that with WireGuard, but that would require that you have a lot of like manual tinkering, like touching and changing all those kind of things. I was wondering if there's something more automatic in relation to that. So I found I am actually a current user of Tailscale, and I found that it's great for those purposes. Like basically, it just moves from the traditional VPN kind of access into a mesh network. So it allows you to the computers that are routed, that are physically close, so they don't need to go to the VPN hub and then having all that round trip on traffic. So it's kind of cool. The only downside is that, of course, if you wanted to set it up this for your home network, you have certain number of devices, but you cannot have your family members join it. You're limited to one device or those kind of things, and it's great. It's a service. It's a paid service. But I wanted to use this for my home lab so I can access different VMs where I run different services or where I'm testing different things on the machines that I have on my local network when I'm traveling. And sometimes I even use that for remote code development when like my computer is not powerful enough to do those things. So I found that there is something called headscale, contrary to Tailscale, that is a self-hosted implementation of Tailscale, control plane or control server, right? And it offers the same functionality, so it allows the nodes to coordinate and to coordinate the connections and then be able to exchange all the encryption keys and things like that in order to be able to use WireGuard then later to connect between the nodes, right? Um, but since I have never deployed this, I have never done this, what I wanted to do is try to test this out on my local machine with some VMs without having to go to the cloud, like deploy a server and start playing with it and see how it goes, right? So what I have on my local setup right now, I have my machine, the one that I'm running here. So this is going to be the host. This is the one that's going to run headscale. And I'm going to run headscale inside a Docker container. I'm going to map that. And then I'm going to have two nodes that's going to serve like the different machines that I'm going to have. And those nodes are going to be running in QEMU. That allow me to like try different things, right? In this particular case, I'm going to use Alpine Linux as the distribution, but it shouldn't vary a lot, right? So for running things on Docker, I set up here a Docker Compose file, so I don't have to like type it in all the commands all the time, and I'm using the official headscale image that is on GitHub, the latest version, and then I'm passing the command to serve to run that. Listening on the specific virtual bridge for the QEMU server, QEMU, well, sorry, I cannot pronounce it correctly, and then setting up the IP address for that, which is it's going to only listen there, so in case that something wrong happens, but I'm just wanted to listen on that specific address. And then I'm mounting the configuration so I can tweak the configuration locally, and then I'm using a volume to store whatever is the output, like state configuration files it generates, etc. Right? So on the configuration, actually, when you follow the guides on headscale documentation, you can have like download the binary, set it up the configuration, create a user, all those things. So the documentation is great. Highly recommend that you go and take a look to it. I just extracted some of the configuration example file to see all the stuff that you need. So basically you need to tell what is going to be the server URL. So this is the one that is advertised to the users. The listening address, so where the headscale server is going to be listening. And since I'm going to be running that inside a container, I need to listen to all addresses within the container. Then the private key and the noise key, private keys are going to be automatically generated. And you see on the path here, I indicated bar live headscale, so that's the mounted volume, so it's going to be generated there. And then the IP prefixes is what IP ranges are going to be provided to the machines that are that connect on this network. And of course you can list here multiple IP prefixes, and those IPs are going to be given to each node that gets added to the network. So that's what I understood. Right now I commented out the one for IPv6, and I'm only going to limit it to IPv4, but you can read all the documentation on the configuration example. It tells you what are the default values for those kind of things. So it says that the values here, it seems to be arbitrary. You need to keep those into the IP ranges supported by the Tailscale client, because we want to use the Tailscale client. I disable the check for automatic updates because, well, this is just a testing. Pointing that to be using SQLite 3. The idea here is that I wanted this to be simple for my testing. I don't want to have to later on deploy a Postgres database, connect, and like this is just for like I don't know, 10, 15 machines and my mobile devices and things like that. So it doesn't need to have like a lot of those kind of things. And later on, thinking like when I deploy this, I would like to have something more like Lightstream to be able to replicate this configuration and be able to save the state in case something goes wrong, right? Logging, DNS configuration, you can override the DNS that are like inside of each of the machines. So if you want to choose like Cloudflare DNS, or you want to choose, I don't know, Pi-hole, which has its own DNS server that you have it on your local network, you can go and instruct here. And I enable the magic DNS that's going to allow you to, you can read all this documentation in the example file and the base domain, what is the base domain that's going to use. And last but not least, the log tail is like all the authorization, what it says, enable the log tail for the clients. It's currently not support overriding the log server. So basically this is disabled by default. Enable this will make your client send logs to Tailscale Inc. Maybe we don't want that. So I just disabled that for the moment, right? Okay, so I have all this configuration and I have this, the image, the official image. And what I'm going to do here, I'm just going to do, this is an alias for Docker Compose up. I'm just going to do Docker Compose up, right? Now, you will notice that here metrics is not listening on anyone. I disable that. You can decide to configure that, whatever is going to be running. So this, in theory, if I go to a browser and I go to 192, 168, 122, 1 and port 8080, I get nothing. So this is not broken. I just get a 200, and this is the default behavior of headscale. Doesn't render anything. That's it. Okay, but at least we know that it's working. Since you need to execute certain things within the headscale server, because I'm running on HTTP, I don't have certificates and things like that. I will need to get into the server to run certain commands. I noticed that the official image is lacking bash or ash or any type of session, and that's great for security purposes, but for me, for testing, that's bad. So what I'm going to do is switch the server from using the official image to run a local Docker file, to compile a local Docker file, right? So I'm going just to do down, I'm just going to stop the server, and let's open the Docker file that I set it up here. Basically, just kind of like I have this practice of like doing upgrade of the packages, so I get all security update packages, and then I just downloaded the binary for that release, downloaded that, verified the SHA-256 in order to confirm that that's okay, then make it executable, place it in a directory, and then just do a smoke test to confirm that that's working correctly, right? If I do that, if I do a build of that, I already built it, so it should be okay. And that's a little bit bigger. So the original image coming from GitHub is 46 megabytes, and this is 33, so it's not bigger, it's even smaller. Okay, so with that image, now I'm going to just to boot it up. As you can see, it's exactly the same output that was before, and I'm going to see if I can, yes, I can open a process in here, and I can see that headscale is running. I have my ash shell here, and I can do headscale users list. And the concept, each network or mesh network is, if I understand correctly, it's what originally was called a namespace, but now it's being called users. So what we're going to do first is create a user that we're going to use later on to have register all the nodes within that user network. So I'm going to create, let's see the comment, I just need to give a name, right? So I'm going to create homelab. Okay, user created. I can see here on the logs perfectly. Now, if I do the list again, I have the homelab ID created. Perfect. Now, what do we need? We need the VMs. So I'm just going to boot it up, those here. I have node 1, node 2, and I'm going to SSH, let's see, SH net DHCP leases. Let's see, yes, the IP addresses are still, so you can see here node 1 and node 2 on this virtual machines got these IP addresses. So I'm just going to SSH to the first one, and I'm going to SSH to the second one, right? Just going to do that. Now the Tailscale, what we're going to do now is install the Tailscale package within that machine. And the Tailscale package is on Alpine Linux. If I search for Tailscale for 316, it's on the community repository. So that means that I need to enable the community repository. If I do apk search Tailscale, I got nothing. So I'm going to edit the repositories for that. I'm going to enable community. I'm going to do apk update, and if I do a search again, I got Tailscale. Good. Let's replicate that again here. Repositories, I'm going to enable community, apk update, apk add Tailscale. Okay, and apk add Tailscale. Okay, Tailscale is installed. Now, if I follow the documentation that says running, it says on your client machines, you execute this command, Tailscale up, and you pass the login server, and you pass the URL that we gave here. So if I go back to the configuration, is this the server URL? So tailscale app -- login server. Okay, so I'm going to do tailscale app -- login server, and I paste the IP of that. Oh, I don't have the tailscale service running. So service tailscale start. Okay, and I'm going to try to do the login again. Ah, sorry, it wasn't. I was too quick. Okay, so now I will copy this. This is the URL for adding the node key, and if I open this up in the browser, it says headscale. This particular thing works. It says headscale machine registration. You copy this and you register that within the username for that server. So I will go back here to the server where I have the user. I will paste here and I will change here username to be homelab. When I do that, it says node 1 now has been registered, and you will see here some exchanges about the client's ready to access the telnet, send an initial map handler, things like that, and it seems that gets stuck here. Okay, there's no response. Okay, let's see if I check on the status for headscale. Well, it says is there, and I got the IP, and it belongs to homelab. Okay, now let's repeat that on the other server, right? So we're going to do service tailscale start, and we're going to paste that. Oh, I need to wait a little bit so that starts working, right? Get the other registration with the other nodes. I'm going to copy, and I'm going to go back to my headscale server, and I will do homelab with that node key. And now it says node 2 has been registered, and I see some exchanges here about it. And if I go to node 1 and I ask for status, I got node 1 and node 2. So that's good. If I do ping node 2, it ping, and you see here the IP is the local one with the port, I think if not mistaken, that's the port of WireGuard. So if I do status, yes, here it shows that the connection is active and it's a direct connection towards that. Well, here the same thing looks stuck. I will do tailscale status, and I will do ping node 1. Okay, status again, it indicates active. But what I wanted to do is actually to see if I have names, DNS resolution, right? So I'm going to ping node 1 homelab, and then the domain that I gave, which is luislavena.info, and I got a ping. So it resolves. Okay, the first couple of times were bad, and then started to show 1 millisecond, which sounds logical, right? Because it's basically localhost. Everything is on the local machine. It's a direct thing between just the virtual bridge that I have here. Okay, so that's good. This is working. And now if I go to headscale, to the headscale console and do nodes list, I see both are reported online, last seen, basically just now, the IP addresses that were given, and if it's using expiring keys or not, because you have a strategy here on headscale and also tailscale that you can use pre-authenticated keys, that you can create those with expiration time, that you can use, say, for automation or provisioning of machines that you wanted to do that more in an automated way. Like you just pass the authentication key, and when you do that, those keys can be reused for any nodes that you wanted to do, and those machines are going to be automatically added to your network. So it's kind of cool if you wanted to have like I don't know, like a cloud init or things like that to provision multiple machines that you wanted to get those automatically get added to your network. You can use that key for those machines, and then you can see the configuration. Now, what this means, so if I go to bar live headscale, I have the private keys that were created, right? And then I have the database that was created that will contain the node information, the machine key, and I assume a bunch of other things. I see the host name of the machines, the name that's given into the system, and the IP addresses that were given to each of the machines. And that's it. I mean, okay, this seems to be working. So first caveat was that the machine doesn't have a binary. So if I wanted to later on deploy this to Fly, where I can get into a console, I will need to have a bash server, right? If not, I might not be able to do console, right? The Fly console functionality. So I will need to have this Docker. And later on, if I want to run this through Lightstream, it will allow me to back up the SQL database. I will also need to add that. That's a mistake here. I will need to add that here as a binary, and then maybe tweak the entry point of the container so it's booted up the application through Lightstream, and then boots up the headscale server and starts serving things. So it's kind of cool. I don't know if what are the other settings when I try deploying this to Fly. I will see if I need to for the what's called the derp. There is something called, it's a relay system that allows machines that are behind a NAT, network address translation, to be able to figure it out how to proxy their connection to other machines. And by default, this is disabled. The derp server is disabled. But ideally, you would like to have this server also serve that purpose. But for derp to work, you require TLS. That's what it says. The head server must be using HTTPS. Derp requires TLS. So I cannot run this on my local right now. I will need to do some testing just to check, right? Cool. So next steps. For me, try it out that with the local machines. That seems to be working. Hosting on the cloud might be deploying that to Fly. So we'll try to do that next on the next video. Try to deploy this to maybe improve a little bit about this Docker Compose. This Docker file that will copy the configuration file, because I need to pack everything into one image, and I will get that deployed to Fly to run this. And when I have that deployed to Fly, I will then later on add the backup of the configuration and things like that, so it generates that, so I can safely restore to a point in time in case things go wrong. So this seems to be the minimum configuration that you can do. I think when you have the base domain, this is like what you wanted to use, and then you have the users that you have, and each one of those users have its own list of nodes. So that's kind of like cool. Maybe you can use that in a small company that you wanted to separate multiple computers. Something that I didn't look in this is that you have ACLs, so access control list. You can use a policy, and with that you can define which machines or which nodes have access to which other things. So that's kind of cool. So I would love to explore that a little bit further later on, and that will be my next objective. So that's all. Thank you for watching, and if you reach out this point, just let me in the comments anything that you wanted to see or you wanted to explore. Thank you for your time. Have a good day. Bye bye.